Hello, students. I wanted to share a video with you about a graphical interpretation of the derivative. So you've just begun learning about derivatives, and I wanted to emphasize one more time that the derivative is a function that describes the slope of a tangent line to a graph at a given point. So I'd like for you to really recognize that the derivative is a function about slope. And so therefore, when we graph a derivative, we're actually graphing what the slope of the tangent line would be to the original function. So what I'd like for us to do today is to examine some original functions, and from those be able to graph a sketch of the derivative. And so we're going to take a look at an example that I have down at the middle of your page. So I've drawn just a cube graph, and we're going to take a look at some different points about that graph, and then come up with a graph of the derivative of that function. So the first thing that you should note is, where is this original function increasing? And I'd like for you to determine the intervals. So by increasing, I mean where is this graph going up as you look at it from left to right. And so I'm going ahead and writing in here where the graph is increasing. And you'll see that as we look at this from left to right, that it is increasing from negative infinity until we get to where x is -1. So one of the intervals would be from negative infinity to -1. But this graph is also increasing in this section right here. It's going up as we look at it from left to right. So again, increasing. And that begins, and I know you can just barely see this, but the x is at -1, or excuse me, at +1. So at +1, and then continuing on to infinity. So those are the x intervals. The intervals are always representative of x's. All right, so what we're going to find is that when you have an increasing function, if we were to draw little tangent lines anywhere along where they're increasing, the slopes of those tangent lines would be positive. So whenever you have an increasing original function, the slope of the tangent line would be positive. They would be positive slopes. Well, so now you have to interpret, where would this graph, if we were to graph those positive numbers? Well, if you think about a graph, the positive numbers are graphed above the x-axis. This is where your positive y values are graphed. Remember, your x's are from the intervals. So when we talk about positive values, we're talking about positive y values, because your ordered pairs are going to be made up of x's from the interval and then whatever the slopes are of your tangent line. That's what your f prime ordered pairs are going to be made of. So when I'm asking you where or what this would mean about the graph of the derivative, it means that those ordered pairs would be above the x-axis. Keeping in mind that f prime, which is the graph of this derivative, would have ordered pairs made up of the x's from your intervals and the slopes of the tangent lines. All right, so we'll move on and look at where the graph is decreasing. So if we look at that, the graph is decreasing in this section right here. And so I think you can probably surmise that the tangent lines along a decreasing section of the graph would have negative slopes. Remember that negative lines would fall as you look at them from left to right. So negative slopes. And so if we were to graph f prime here, again with the x's from our interval and the slopes, when the slopes are negative, then they're going to occur below the x-axis. So let's identify the interval where that would occur. And so it begins when the x is -1, and it ends when the x is +1. And there's only one interval in this graph where the graph is decreasing. So in this case, your points in that section would fall below the x-axis. And finally, we're going to look at where the graph of the original function is at a maximum or a minimum. So we have a maximum right here. We have a minimum down at the bottom of your screen. And you can't see the ordered pair very well, but it doesn't really matter. It matters that you can see what the x value is. So if we were to draw, so we have, excuse me, I'm going to write those x values down. We have one at x equals -1, and we have another one at x equals 1. We have a maximum at x equals -1. We have a minimum at x equals 1. Well, what does this mean about the slope? Well, if I were to draw a tangent line at the maximum or at the minimum, the line would be horizontal. Now, that doesn't answer my question, but it does help me answer the question. I would have a horizontal tangent, and so the slope, I actually know the slope. The slope of a horizontal line is 0. So once again, when I'm thinking about the graph of my derivative, then if my slope is a 0 and I know the exact x's where I'll have those maxes or mins, I actually can know 2 points that are on my graph of the derivative. One is when x is -1. And remember, my derivative is made up of x's, where I have these different characteristics going on, and then my y value is the slope. Well, one of them happens to be at -1, I have a slope of 0, and at +1, I have a slope of 0. Now, I wanted to analyze it this way first in kind of narrative form. But for practical purposes, I really think that organizing your information in terms of a table is going to be very helpful for you. So I will, from this point on, use a table that will have at least 3 columns in it. As we learn more about derivatives, we may add another column. But the columns in the table will have, first of all, the intervals that we're interested in. Secondly, the sign of f prime. And by that, I mean, is it positive? Is it negative? Or is it 0 or undefined? And then the characteristic of f, your original function. Sometimes you'll be able to fill in the middle column first. Sometimes you'll be able to fill in the third column first. always will set up our intervals by looking at what's going on. So we already really established our intervals. I'm going to go ahead now and put them in the table for us. And so the first interval that we looked at was, we always want to go from left to right. So negative infinity to -1. Now I include in the intervals a place for us to put what's going on at the right hand value when it's a number. So I would want to know what's going on at x equals -1. And I realize that's not an interval, but this is a nice row to have in your table. Then our next interval that happened from left to right is where it was decreasing from -1 to 1. And so since that interval stopped at 1, I want to know what's going on at 1. And then my final interval was from 1 to infinity. And in this case, we actually had the original function first. So we looked at the characteristic of f before we looked at the sign of f prime. So the characteristic of the original function from negative infinity to -1 is that the function was increasing. And you can either write that word out, or if you just want to abbreviate it, that's fine. We looked at from 1 to infinity that the function was also increasing. And so whenever we had an increasing function, then we talked about that f prime would be a positive. Now, usually I'm just going to use a plus sign to indicate that it's positive. And I'm also, just to help remind you, going to put that means it'll graph above the x-axis. So whenever we had an increasing function, the graph will graph above the x-axis. And then I like to do the intervals first and then go back and pick up the maxes and mins. So we had our interval from -1 to 1. We noticed that our original function was decreasing. And so we determined that those kinds of slopes would be negative and would graph below the x-axis. So below the x-axis. And then at -1, when x was -1, we noticed that we had a maximum on this graph. And so we had a horizontal tangent. And so the f prime actually was the number 0. And likewise, at +1, you had a minimum. We noticed that the sign of f prime actually was a 0 there. So now we're ready to move on to graphing the derivative. So I gave you an empty graph to graph the derivative. Now we have two ordered pairs that we actually know exact values for. One of them is when x is -1, the y value, which is the slope of the tangent line, is a 0. So we have the ordered pair -1, 0. And when x is +1, we know that the slope of the tangent line, which is the derivative, is equal to 0 because we had a horizontal tangent. So we know those two ordered pairs. And then for the rest of the graph, now I'm going to go ahead and just, I'm not going to go to the colors here. I'll just use black for this. But we had from negative infinity to -1. So when your x's are on the far left, they need to be above the x-axis. Now, I don't know where above the x-axis, but I do know that it stops being above the x-axis when I get to my x being -1. Then when I'm in between -1 and +1, my graph has to be below the x-axis. Now, I don't know exactly where, but I know that it has to be below and it has to be ready to go above the x-axis by the time I get to 1. So I can't just let it keep continuing below because that won't be ready to go above the x-axis. So I've got to take it below and then bring it back to when x is 1 so that from 1 on to infinity, the graph is above the x-axis. Well, what you see is a graph of your derivative looking like a parabola. And no, you don't know the exact points, and that's okay. You're doing a sketch of the graph. But what's following is that these two sections that are above the x-axis are where your original graph was increasing, and this section where your original graph was decreasing is where you are taking the derivative below the x-axis, and that's what you want to be focused on. You can also take note of algebraically that your original function looks like an x to the third power, and so your derivative, if you bring the coefficient in front, would be a 3x to the second power. So you have a some kind of a parabola going for the derivative. So there's your example on analyzing graphs. It is analyzing, so this is a more difficult skill, and it's one that will take you some time to think about and work with. Now, I do have an example at the bottom of the page. It's a very quick one. I'm going to clear this ink and go ahead and just continue with that last example. So I'll clear this ink, scroll down, and pick up this last one. I just thought it was worded in a way that I wanted to hit this with you. So your second example is where you have information, the tangent line y equals h of x at the point -1, 4, also passes through a point 3, 6. I'm asking you to find h of -1 and then h prime of -1. Well, h of -1 is very simple. H of -1 simply means tell me what the y value is when your x is a -1. Well, you have that right here. So h of -1 is 4. Your y is a 4 when your x is -1. H prime of -1 is really a vocabulary question. I'm wanting to know whether or not you know what a derivative is, because a derivative is the slope of the tangent line to the graph at a point. Well, the point that we're looking at is -1, 4. If I have -1, 4 and 3, 6, I can find the slope using my formula for y2, which I'm going to use the 3, 6. So y2 minus y1 over x2 minus x1. And that would simplify to 2/4, which would simplify to 1/2. So h prime of -1 is 1/2. And it really is that simple. The derivative is the slope of the tangent line. And if you don't know a function so that you can use your power rule, then you have to use the information that you do have. In this case, you have 2 points. You can use algebra and find the derivative by finding the slope of that tangent line given the 2 points. So those are your examples for today's lesson.